All right, we've been talking about sequences last time. I wanted to do a few more, a little bit more sort of like down-to-earth examples about sequences. I thought we should just try a few finding the limits of sequences. Finding limits of sequences. At the very end last time, I wrote down a big list of rules for limits. And these rules for limits, we are usually not going to think about them. We will just kind of naturally do them sort of in the back of our mind. But anyway, here's an example of a typical limit. Lim n goes to infinity. Sorry, I meant to write n over n plus 1. Like I said last time, often we are not going to write the little n goes to infinity because if you're talking about a sequence, that's the only thing n goes to. In a sequence, n starts with 1, 2, 3, 4. It doesn't go anywhere other than infinity. So oftentimes you'll see people just write lim. But anyway, what is this limit? This looks very much like the function x over x plus 1. And there's a standard trick that you do if you're dealing with those kinds of functions. And that is you just divide through everything by the highest power of n. So this is a standard trick. Divide all by the highest power of n. And in this example, the highest power of n is just n to the 1. I don't see any higher powers, but if I did, I would divide by those. So I'm going to divide everything on the top and the bottom by n to the 1. So this will be the same as up top, it'll be n over n. Down here, n over n plus 1 over n, right? And then simplify. Those n over n's are 1s, and it looks like that, all right? And now that all the n's, the purpose of doing this little trick is to make it so that every n is in a little denominator somewhere. And that is the case at this point. Every n that you see is part of a little denominator. And so now I can do this lim n goes to an infinity. And that 1 over n becomes a 1 over 0, not 1 over 0, a 0, right? Because that n in this little denominator makes this little piece equal 0 because this is a fraction where the denominator is becoming infinite. So that is 0, and so, of course, this, you can simplify that. It's just 1, all right? This is a typical trick, divide everything by the highest power of n. Now, those rules about limits that I wrote, a big list of those rules last time, I actually used several of those rules right here without saying it. And this is what I mean by, like, I'm not going to tell you to memorize all those rules because you're just going to naturally do them in the back of your mind. But actually, it was this step right here where I used a bunch of those rules. So if I were to write this out in detail, which I don't really suggest, and when you're doing this on our homeworks or quizzes or whatever, I would not expect you to write this. But really what I did here was, first of all, there was a rule about limits of quotients, and I did this. I said that's the lim on top and also the lim on the bottom. And then there was a rule about limits of sums. This is a limit on top, and then I can break the limit on the bottom like that. And then I actually do all of these limits. The limit of just 1 is just 1 because there's no n in there. The limit of 1 is 1, and then here, limit of 1 over n is 0. All right. So right in that step, I use the rule about limit of a quotient and then also the rule about limit of a sum. But these are not things that you really think specifically about usually. Typically, you're going to do these in the back of your mind. The reason I mention all the rules is just so that we can all feel good about doing this in the back of your head. It is actually legal to do these steps because of all those rules that I wrote last time. All right, let's try one that's a little fancier here. How about 3n over square root n plus 5? All right, I'm going to try to do the same trick here, dividing everything through by the highest power of n. And again, in this case, the highest power of n is n to the 1, which I see up top. I also see n to the 1 right here, but this being inside of a square root means that sort of counts as if it were n to the 1/2. And so that would not be the highest term. Anyway, it's up here. So I'm going to divide everything through by n. So it will say just 3 up top, right? And then on the bottom, maybe this is a little confusing when you have the square root in there. Maybe first of all, I'll just write it like this. Dividing by n on the bottom, of course, is the same as multiplying 1 over n on the bottom. And then how exactly do we interact the 1 over n with the square root? We can move the 1 over n inside of the square root, because I intend to like cancel it or whatever with what's in there inside the square root. We can move the 1 over n on the inside, but it will become 1 over n squared. So what it will look like is this. When that 1 over n moves into the square root sign, it becomes a 1 over n squared. We've done this several times when doing those weird like trig substitutions or something, moving things in or out of a square root. Like when you factor a constant out of a square root, you have to do the square root to it. But when you factor a constant into a square root, which is what we're doing here, we're pushing 1 over n inside, you have to square it when it goes inside. All right, anyway, this can simplify, I suppose, a little bit. I have n over n squared, which simplifies to 1 over n. So this says lim 3 over, like this, 1 over n plus 5 over n squared. Right, and then we do the limit now. So now, again, all of the n's in the whole thing appear in little denominators, and so I can take the limit, and everything where you have one of those little denominators with an n will turn into a 0. So this, I get 3 up top, and then it says square root 0 plus 0 down there. So this is actually 3 over square root of 0, I guess. Square root of 0 is 0. 3 over 0, and what's your interpretation of that? You should feel a little strange about 3 over 0 as an answer. What do you say? Yeah?
Infinity.
Yeah, you could say the limit is infinity, or you could say the limit does not exist. I'm typically going to say the limit does not exist, or you could say it diverges, whatever. Any of those things would be acceptable. Usually I would say the limit does not exist. You could say the limit is infinity, although generally you need to be a little careful. If you see 0 in the denominator, this could indicate the limit being infinity, or it could also be negative infinity. This one is positive infinity, but I don't really want to get into that. So I'll just say the limit does not exist. All right, excellent. Another trick that you can do in these kinds of situations, which I didn't do, but actually we could have done right from the beginning. This is n over n plus 1, where n is becoming infinity. That means this is like a fraction where both the numerator and denominator are becoming infinite. This is a situation where you could use L'Hopital's rule, and I mentioned that last time. So actually in both of these examples, you could have instead used L'Hopital's rule, and that would also work. All right. If you ever like talk to sort of like fancy academic mathematicians, there are a lot of L'Hopital rule haters out there. There are some. I have never really understood the hate, the vitriol, but there are some people who are like, L'Hopital's rule is just for idiots, and you should do it by hand, which meaning this kind of a thing. Instead of doing L'Hopital's rule, you should always work it out in this way. I don't mean like, this is not like, I hear these kinds of hot takes a lot from like high school teachers or people just talking about the proper way to teach something. You should always do it this way versus that way. But this is actually like abstract mathematics researchers who have hot takes. I don't fully understand it, but if you're ever trying to impress someone in the club or something, tread lightly when talking about L'Hopital's rule. There are haters out there. Okay, one other thing that I wanted to mention, again, this also was something that I mentioned last time. I will just say this particular sequence is an important example. -1 to the power n. This one, and what is the limit of that? That's what I want to talk about. So this is an important example, and you cannot really analyze this using standard tricks from limits of functions. You'll probably recognize this trick that I'm doing here is the same thing that you would have done if these were just ordinary functions with x's instead of n's. But this one right here, you cannot use old-fashioned tricks that you would have used for functions, and that's because, so I'll just say this is I don't know, different. I mean, it doesn't look much like those other ones anyway, but it's very different because, as I mentioned last time, negative 1 to the x is not a legitimate function. Not legitimate in the sense that you don't even get like real number answers for, like if I plug x equals 1/2 there, what that will say is negative 1 to the power 1/2, which is the square root of negative 1, which is not, that doesn't exist as a real number. So this is not even a legitimate function. And so you cannot use old school tricks for functions to analyze this limit if you wanted to find the limit of that. And but I mean, you could, if you like, sort of plot the terms of the sequence, which we will do every so often if we're just completely desperate. The first term, n equals 1, gives me negative 1 for the value. So that's down here. The next term gives me a positive 1, and so on. So the values of this sequence, they do this. This just bounces back and forth, minus 1s and plus 1s, right? So this is sort of alternating negative 1s and positive 1s. Does this have a limit? Well, I can tell just by looking at the picture. These red dots are not actually approaching any particular value. You might say, like, these ones up here approach 1, these ones down here approach negative 1. But overall, the dots as a whole are not approaching any particular y value. And so we say the limit does not exist here. So this minus 1 to the n diverges, which is to say the limit does not exist. All right. It diverges, even though, so diverges, the word diverges just means the limit does not exist. It doesn't necessarily mean it goes to infinity. And this is an example where it does diverge. It just means it does not converge. But also it doesn't go to infinity. It just sort of bounces back and forth and doesn't approach anything. All right? But when you see the minus 1 to the n, that doesn't automatically mean that whatever you're talking about diverges. For example, how about, this is another important example that we'll be talking about every so often. How about that? Negative 1 to the n divided by n. So the way that, when you see this, the way I sort of, the impression that I get when looking at this is, okay, this thing up here makes it alternate in signs. It goes negative, the first one will be negative and then positive and negative and positive. And then what else do I see? I see 1 over n otherwise. So this looks like, well, the terms are negative 1 over n, and then positive 2 over n, and then negative 3 over n. What? Sorry, I shouldn't be writing n's here. I'm trying to write, this is totally wrong, sorry. The terms are, can I have a do-over? Negative 1 over 1, and then positive 1 over 2, negative 1 over 3, positive 1 over 4, etc., right? The bottom there is always equal to n, and the top is either plus 1 or minus 1, and it alternates. Starting with minus 1 because I'm starting n equals 1. All right? Does this converge? We have alternating signs, so that you should feel like when the signs are alternating, it's probably not going to converge. But we also have these denominators. If you graph these things in the same way, what's it going to look like? So the first one is negative 1. So that's down here, right? The next one is positive 1/2. That's up here. The next one is negative 1/3. So it's down here, but it's getting closer to the x-axis there, right? The next one is positive 1/4, which is like here. Then negative 1/5, positive 1/6, negative 1/7. I don't know about you. To me, I think this does converge. These dots, they do seem to be approaching, they approach 0, I would say, all right? So this one here converges to 0. So it is a fact. The lim minus 1 to the n over n actually equals 0, right? At least that's what it looks like on the picture. How could you actually show this sort of using our various rules for the limits? I mean, it would be nice to be able to work this out rather than plotting the values and just kind of looking at where they go. So how to sort of show, using the formulas or whatever, our rules for the limits, that this equals 0. It's a little tricky because of the alternation up top, right? -1 to the n. You cannot use the quotient rule, you know, say, I don't mean the derivative quotient rule, I just mean like this limit here, I can split it up into the limit of the top divided by the limit of the bottom. This actually is not valid because the limit on the top diverges, right? If you take the limit on the top, you don't get an answer, and so you won't be able to divide them and get 0 for your final answer. You might think of using L'Hopital's rule, but this also will not work. L'Hopital's rule only works when you get something that looks like infinity over infinity. Now this n on the bottom will go to infinity, but this -1 to the n on the top will not go to infinity. So L'Hopital's rule also is not applicable. The -1 to the n is really the thing which is a pain to deal with. And here's a cute trick. So this is a trick to deal with -1 to the n when you're trying to take a limit of it. To show that some limit of an equals 0, it's equivalent, this is the trick, to show that lim of absolute value an is 0, right? If your goal is to show that the limit of some sequence is 0, that's actually the same, because the absolute value of 0 is 0. It's the same as showing that the limit of the absolute values equals 0, right? These are exactly the same thing. If the absolute values go to 0, that means the original sequence goes to 0, because the absolute value of 0 is the same as 0. All right, so that's my strategy here. So how to show this limit equals 0? I'll just say, instead, we'll show that the limit of the absolute values is 0. And this, usually I don't really like absolute values because sometimes they're hard to understand, but this is actually much easier. Instead, we'll show that this equals 0. And that is a lot easier in this particular example. So what is it? We have, here's how we show that. Lim absolute value -1 to the n over n, right? What happens with the absolute values? So absolute values, like I said, you probably know, are kind of a pain to deal with sometimes. But here we can simplify the absolute values very nicely. If you have a fraction, taking the absolute value is the same as doing absolute value on the top and also on the bottom. So this is the same as lim absolute value of the top divided by absolute value of the bottom. That's just a rule about the absolute values. Can anyone say, what is the, can we simplify absolute value on the top? -1 to the n? What do you think? You could think about, for various n, what are those numbers? And then what happens when you take the absolute value of them? Yeah? It's the same as just 1. I think they're all 1, right? If you think about what those numbers are, these are alternating -1, +1, -1, +1. When you take the absolute values of those, they're all 1, right? Because they're either -1 or +1. Doing the absolute value, they all become 1. And this is sort of the heart and soul of this trick here. Suddenly, there's no -1 to the n anymore, and we can proceed with no problem. What about on the bottom, absolute value n? This is the old, my favorite technique for dealing with absolute values. Like when I was a young lad, when I was just a kid, my technique was, I just ignore the absolute values and hope that everything works out okay. Maybe you're experienced with this technique. I'm just going to ignore the absolute values. Is it okay? The question you should have is, well, what about if n is negative? And my answer is n is not negative, because I'm talking about sequences here. This is not like an ordinary function. N starts at 1, and then 2, and then 3. So n is not going to be negative. So when you're dealing with sequences, absolute value of n is just the same as n. All right? Okay, anyway, what's the answer? Lim 1 over n is 0. And this is what we were trying to demonstrate. So that means lim of the absolute value minus 1 to the n over n is 0. So that means lim of the actual thing without the absolute value is 0. That's the basic idea. Sometimes it gets easier when you take the absolute value. That's the moral of the story here. All right. Okay, one more rule for the limits, and then I have some for you all to try. One more limit rule. And actually, I have used this rule at least once this morning without anybody noticing. One more rule. This one looks stranger, but actually is also very familiar and something that you will just naturally do without really thinking about it. It is if f is a continuous function, this is a little weird to be talking about continuous functions in the context of sequences because, as I've said, a sequence doesn't really have continuous values. It just has individual sort of dots on the graph. But anyway, if f as a function is a continuous function, then here's one last rule about limits. Lim n goes to infinity of f of a n is this. You can push the lim inside of a function, provided that that function is continuous. I should also say this also requires that an converges. If an diverges, you're not allowed to do this. So if f is a continuous function, can I just squeeze that in here? Sorry about that. And an converges, then this is true. You can push the lim inside of a function. All right. Did anyone notice when I did this earlier? Probably not, but it was right here. I did this limit, and in order to do this step, I actually did the limit inside of the square root sign. I don't know if any of you got worried at that point. Are you allowed to just do the limit inside of a square root? The answer is yes, because the square root sign is a continuous function. And that's what I did here. This, if you think of the f, if the f was like a radical sign, what you're doing here is taking the limit inside of the radical sign. All right, but this is true for any function. So you can take the limit inside of a sine or a cosine or a natural log or e to the x or something like that. All right. So for example, here's just a simple example. What is limit of cosine of 1 over n? And going to infinity. Using this rule, because cosine is a continuous function, I can think of doing the limit inside of the cosine. So this should be the same as cosine lim 1 over n. A lim of 1 over n is 0, of course, so this is cosine of 0, which is 1. And that's how you would figure out this limit. It requires doing the limit on the inside of the function. Again, I would not, typically, I would not even write out this step in the middle. You're just going to naturally look at this and say, well, when n goes to infinity, I only care about where the n is, right? This cosine doesn't really matter. It's just going to hang around as part of our answer. But where the n is, I make the n go to infinity, and that becomes 0. All right. Excellent. I got a few for you. I got 2 for you. The first one is a little more straightforward, and the second one is a little fancier, I suppose. They both look kind of fancy. N squared plus 3n over square root n to the 10 minus 7n cubed. There you go. And the second one here. All right, I'm going to give you some hints. For the second one, my hint is to do that inner limit first. And for the first one, I will say you should use the divide by biggest power of n trick. But as a cautionary tale, my hint is the biggest power of n here is not actually 10. Has to do with the fact that there's a square root sign there. You have to think a little bit differently about the power in the bottom. I'll let you think about that. Decide which power you're going to divide everything by.
Just n. Oh, n squared. Oh, yeah.
Also should do that. This into the 10, being inside of the square root, it should count as something else, but that actually is a bigger power than those ones.
Oh.
Because here, once you do that, you're going to get some like n to the 8 from there.
Yeah.
But you want it so that all your n's are in little denominators. So n to the 8
Oh,
is
okay.
not good enough. You have to divide
Yeah,
by
yeah.
four. How's it going? What did you divide by?
Square root of 10.
It's simpler than that. Remember that whatever you're going to divide by, when it goes inside here, its power gets doubled. Yeah, I like n squares of 10.
Okay.
How's it going? Yeah, the highest power, it comes from this term. This term is inside of the square root sign. So I see a lot of confusion about which power to divide by. Remember, the things inside of the square root sign, you should consider these powers as if they were sort of like half of what's written, because they are inside of a square root, which is like a half power. So this is my hint. So the highest power in this case is, it comes from this part, n to the 10, but it's not actually n to the 10. It's something a little bit different. Yeah. Yeah. And then you're going to move this inside and it will become 10. It will cancel. I always tell people to chat with their friends. You guys. You have to do that. So then you're going to push it inside here. How's it going? comes in and it comes into the 10. I would say simplify whatever you can. Like this is 1.
Yeah.
This would be, you can subtract the exponents, right? So it would be 1 over n cubed.
Yeah.
This is like 5 ends down here and 2 ends up here, so you cancel 2.
Yeah, 0, 1. Yeah. Yeah.
Still good? I would cancel this one over. Still good here? You still need this squiggly sign here? Yeah, but this, when this moves inside, it becomes,
I think for the part, the power.
This one cancels.
Yeah,
This
yeah,
one
I think so.
This, because here also it's a 2. When you bring this in, it turns into a left-hand power. This one would be in the 10 over into the 10. Because when you move this inside, it becomes 10 squared. So this is simple. Come along. This is 1 over into the 5. You bring it inside, and it turns into 1 over into the 10 because it has to get squared. Yes, yeah, this step here is not allowed because actually this one, right, ends counting. So it's not 0, and that rule you're only allowed to use it if the top and bottom eventually converge, which in this case they don't. So I would say, I would suggest do what I suggested. Reiterate my suggestion. Yeah, try and figure out the limit just of that fraction part first, and then see if we can. Once you do that, you can plug it into it. How'd it go? That's pretty good. And then you finish it off. Which was the only step. Something like that. Yeah, I would say. I don't really like writing infinities, but 1 over n cubed at least becomes 0 because n is becoming. Yeah, and same here and here. That's You could, yeah. You're just focusing on this part. Yeah, if I were just doing that part, I would divide in square. Although, how are you gonna handle the -1 to the whatever? I would suggest, like, if I was writing my answer, I would just do that part first, just the limit of the fraction part first.
Okay, so I should divide
Take
it.
the absolute value and do this dividing, yeah, divide it sort of thing. All right, I want to talk about these because I had one more little thing to say before we go today. Actually, it may be too late anyway, but let's try this out. People did pretty well on the first one. I'm not sure anybody totally finished the second one, but let's talk about the first one at least. Well, I'll just drag it. This one here, I would, so everybody eventually figured out we should be dividing by n to the 5. That's because I see the biggest power I see is n to the 10, but it's inside of a square root, so really it only counts as n to the 5. So I'm going to divide everything through by n to the 5. This will say n squared over n to the 5 plus 3n over n to the 5. Down here, all right, I could write it like this, first of all. And then I'm going to push the, in the denominator, I'm going to push that 1 over n to the 5 inside of the square root, where it shall become a 1 over n to the 10. Now, up top, maybe I'll just simplify these guys a little bit. This is 3 over n to the 4, okay? And on the bottom, multiply that into the square root. It becomes 1 over n to the 10 because you have to square it when it goes into the square root sign. So this now looks like square root n to the 10 over n to the 10 minus 7n cubed over n to the 10. All right? This is me distributing this into the square root sign. And it turns into n to the 10s when you do that, because it gets things, when you push them into a square root sign, they get squared. When you factor them out, they get square rooted. All right, and then can we continue to like simplify these little guys? N to the 10 over n to the 10 is a 1. So 1 over n cubed, 3 over n to the 4. Down here, square root 1 minus 7 over n to the 7, I guess, when you cancel out the powers of n. All right, and now we can just take the limit through everything, because all my n's are in little denominators, and so each of those individual fractions that I see there becomes 0. So this becomes 0 plus 0 over square root 1 minus 0. And the answer is 0, right? This is 0 on top and 1 on the bottom. So it converges to 0. Any questions about that one? This is how we do that one. Ooh. All right, and the other one. So the other one is sort of a different bunch of stuff that you need to be concerned about. My suggestion was, as I was walking around, some people got started on this. Nobody obeyed my suggestion, which it's all right. You can live your life the way you want. It's a free country. So far, at least, am I right? This thing here, I am going to consider this by itself first, and then we'll figure out how that sort of plugs into the rest. The reason is because, the reason I want to consider this separately, so I'm just going to say something like, first, I'll do lim of just this part. I think in my experience, people doing like math problems hate to do it in 2 separate steps. I don't know why this is. Sometimes you just got to embrace it. I'm going to do this part first, and then I'm going to plug that into the rest of it. Everybody always likes just writing this equals this equals this equals this, and then you get the answer. Sometimes it's far better to consider a little piece of it first and then do the rest of it. Anyway, I'm going to do this first. The reason to consider this one by itself is because this -1 to the n plus 1 is a pain to deal with. And the appropriate thing to do is instead consider the absolute value, all right? Where you would not want to consider the absolute value of the whole thing, because that is inside of all this business. Really where you want to do the absolute value is just right there. And so the way to actually work this out is to only consider this little part of it. And now I'm going to do this. Well, I'm going to do this. I take the absolute value, so I say lim absolute value minus 1 to the n plus 1 times n over n squared plus n. We do the absolute value on the top and the bottom. So on the top, it will say absolute value. And in fact, there is a rule for absolute value of a product, right? When you have things multiplied together, you can just take the absolute value of each one. Sorry, those are all absolute value signs. They're not ones or L's, except there are some ones in there, but I hope everybody can tell what's an absolute value sign and what isn't. All right, so I did the absolute value of the fraction is the same as absolute value top divided by absolute value bottom. And then on the top, there was this multiplication here, and I split the absolute value across those 2 parts. And then can we simplify the absolute value? Here's a little warning. I hope you all know. You are not allowed down here, you are not allowed to make that into absolute value n squared plus absolute value n. This is not a legal rule for the absolute value. If it's multiplied, you can do that kind of thing, but not if it's added. But anyway, up top, what is absolute value minus 1 to the n plus 1? It is 1, Remember, this -1 to some power, actually it doesn't even matter what the power is. The fact that the power says n plus 1 is totally irrelevant. -1 to any power is always either +1 or -1. And so when you take its absolute value, it is +1. So that's a 1 times. What can I do with absolute value n? Just like I did a few minutes ago, n is always going to be positive in these problems because I'm talking about a sequence. So absolute value of n is the same as just n. So up top, it just says 1 times n. And on the bottom, you should ask yourself again, can I just throw the absolute values away? The question is this always going to be positive, n squared plus n? And I think the answer is yes, because n is positive. That means n squared is positive, and when I add two positives, I get a positive. All right, so this is n squared plus n on the bottom. All right, so overall, the limit I'm talking about, let me just write that again, n over n squared plus n. All right, and how do I handle this limit? Anybody got a suggestion? Yeah?
Divide everything by n squared.
Right, do the old divide everything by the highest power of n. Or if you're not a hater, you could do L'Hopital's rule, although let's do what she said. Divide everything by n squared. That's the power of n that I want here. So it's n over n squared over n squared, n over n squared, right? Simplify those. This is a 1 over n up top, and then on the bottom, 1 plus 1 over n. And then doing the limit makes those 1 over n's into zeros. So this equals, this is the step. By the way, I hope that everybody wrote lim every time. I haven't been doing the limit at all. I've just been like re-simplifying this stuff on the inside. Now, finally, we are actually doing the limit. 1 over n turns into 0. So this is 0 over 1 plus 0, which is 0. All right? So that means this limit of this part was 0. And now it's very easy to finish what I started with, right? If this is really what I want, I'll say now, so the lim of ln 3 plus that other business, minus 1 n plus 1 times n over n squared plus n. All right, we already determined the fraction part inside there, its limit is 0. And really what I'm using is the rule about pushing the lim inside of a function. ln is a continuous function, and so this is the same as saying ln 3 plus lim of this business, right? And that is what we already determined to be 0. So my final answer is just ln of 3. Right? This one is actually, I would say, very hard to write all in one big long sort of step with equal signs, because you have to separately consider the absolute value only on this part. The absolute value, you don't want to put the absolute value around the whole thing, because there's no way to, it'll be sort of stuck out there. You can't push the absolute value signs inside of the natural log and the 3 plus like that. All right, I said I was going to do a little bit more, but I don't think there's enough time for that. So maybe we'll leave it at that. Let me know if you got homework questions. I will remind you, so the homework has problems about improper integrals and arc length, and so that will be what's on the quiz. Check out your test to see if you already got those ones right. If so, you don't got to do them on the quiz. See you Friday.